Hello, class, and this is Mixmaster Math, M cubed, otherwise known as Rob the Mover, your teacher, Mr. Mott. And we are continuing through the Unit 8 exam review. And I'm going to do two more problems, hopefully, on this video, 13 and 14. So if you are needing help on these ones, I'm seeing a couple of things here that may confuse you. The first thing I do when I look at number 13 is I notice that point O is actually not on line segment DC. So be careful there, right? There's nothing about the center of the circle that's going to help us on this problem because the center is not on that segment. Okay, so we got to be careful here. This is merely checking if you know the relationship of the pieces of these segments, right? These are two chords intersecting inside the circle, not on the center. So the equation is pretty simple. A lot of you have an easy time remembering this. I'm going to take x times x minus 4. Again, be careful there. That is the whole segment x minus 4. As I mentioned in the previous video, back up here, we had this situation come up on number 11 when we were subtracting an expression. Make sure when you're multiplying an expression, put it in parentheses. Equals 4 times 3. Okay, those segments of the chord, those two different segments of the chord multiplying together are equal. So the two products of the segments of the chords are equal. Okay, now when you look at this, hopefully you're thinking it's got an x squared in it. It's different from the situations where we have something like x minus 4 in parentheses squared equals a number, right? In that case, we are able to take the square root of both sides, plus or minus, and then that breaks it down into just x minus 4 on the left equals some number plus or minus, and we can easily solve using algebra there. However, this problem is we don't have some expression of x being squared, because when we multiply this through, we're going to have x squared minus 4x equals 12, okay? So let me erase this over here. So we got to be careful here. This is a situation where you're probably going to have to factor, okay? You see you've got a middle term, right? You got this middle term 4x that's kind of screwing up our perfect square. But you could actually complete the square here and solve. That's going, usually that's a little messy, right? We don't have to complete the square unless we have to. I'm going to go ahead and subtract the 12 on both sides, set this equal to 0. X squared minus 4x minus 12 equals 0. Okay, so this is a factored situation. We're looking for factors of negative 12. So numbers that multiply to get negative 12 that will add or subtract, however you look at it, to get 4 in the middle. So two numbers that positive and negative will multiply to get 12, but they'll add to get negative 4. So that is obviously x minus 6, x plus 2. Okay. Notice that my answers were not negative 6 and 2. My factors were x minus 6 and x plus 2. Now you got to take the time, like a lot of you don't do, and write this out, right? And I see my seniors having this problem. They've been doing it wrong for like 3 years. Okay, x equals 6 or x equals negative 2. Now you got to ask yourself, do both of those answers make sense in this problem? X minus 2 does not, because that would mean a side length was negative 2. That doesn't make sense. X equals 6 is going to be our valid answer for x, but we want to find CD. I look in my problem, and CD is actually, and here's another place where you guys make a mistake. It's x minus 4, not times x, right? Some of you would say it's times x because you're used to using this formula right here. It's not times x, it's plus x. Okay, be very careful there. Okay, so it's 6 added to 6 minus 4, which is 2. So CD is 8. Okay. Now, number 14 is another place where I got a lot of questions in class. The key to this problem is noting that we have a tangent and we have a radius what is the relationship between a tangent and a radius at the point of tangency. Okay, it looks like it's a right angle, but indeed we do know it's a right angle. Okay, that was one of the things that we needed to know. It was in your notes for that section. We talked about it. Okay, so we have a right triangle, but we only know one side. We're looking for the measure of an arc AB. The measure of the arc AB is right in there. The measure of arc AB is right in there. Okay. But the measure of that arc, remember, is the same as a central angle. So luckily, we have a central angle drawn in here as part of our triangle, right? The measure of that central angle is the same as the measure of that arc. So that angle in there, let me call it X, okay? That angle is an angle in my right triangle. Let me redraw the right triangle. This is my angle X. But I only know one side. This whole side here is 18 plus 7 is 25, right? And the question is, do I know any of the other sides? So the key to this problem is noticing that you have two radii drawn in, but you were only given one of them. But lo and behold, if you were given one of the radii, right, OB is 7, then that means OA has to also be 7. So you got 7 over here. You got 25 over there. We're looking for this angle in here. So this goes back to actually our trigonometry. Very simple trigonometry. SOHCAHTOA. Okay. If you didn't get this problem the first time you did it, try it now. We've got a triangle with two sides, and we're looking for an angle. You should be able to set up. We don't even need to find the third side. You should be able to use one of those SOHCAHTOA. Is it sine, cosine, or tangent? So label your sides. 25 is the side opposite the right angle, which is the hypotenuse. 7 is the adjacent side, not the opposite side. The opposite side's over here. So we know the adjacent, we know the hypotenuse. That is the cosine. Cosine of angle X is equal to 7/25. Okay. I actually don't have my calculator handy. Grab it. So how do we solve that? First, we got to do the inverse cosine of both sides, right? Show your good algebra skills that hopefully I've taught you. The inverse cosine of both sides, we're not dividing by cosine. We're taking the inverse cosine. The inverse cosine of the cosine of x just gives us x. That's the whole idea of an inverse operation, like plus 2 minus 2, like times 2 divided by 2, like multiply by 20, divide by 20, multiply by 29s, divide by 29s, right? Inverse operations. So now inverse cosine of 7/25. Inverse cosine 7/25. Make sure your mode is in degrees. And 73.7 degrees, we're drawing the nearest 100, 7.739. So 73.74 degrees to the nearest 100. Okay? Those are two problems that I think people screw up a little bit, especially because you've forgotten some of the trigonometry. Okay, and in number 13, when you get to your final answer, sometimes you got to have a pretty easy idea of setting it up. Some of you may forget to multiply by the whole expression. Others of you get over here and you can't factor, right, this thing, or you get over here and you find x and then you multiply by x instead of add x. So you got to be careful on all those different parts there. Make sure it makes sense, right? Okay.